friends, my name is Untitled. Hope you have enjoyed my previous videos. Today I am going to post my new video on a class 9 physics topic, that is statement and derivation of law of conservation of momentum. So first of all, I will write the statement of law of conservation of momentum. Statement. This law states that sum of momenta of two bodies before collision is equal to sum of momenta of those two bodies after collision, provided that there is no external force acting. So friends, momentum. This must be a new word for you, but you have heard this word earlier. Momenta is the plural of momentum. Momenta is the plural of momentum. And friends, I hope you must have remembered this word momentum in my previous videos. The mathematical formula for calculating momentum of an object is mass into velocity. By this formula, you can easily calculate the momentum of an object. Now friends, I will make you understand this statement in very simple words. Suppose, as it is given, that we have to consider two bodies. So let there be two bodies, body A and body B. This is an object A and this is an object B. So this statement is trying to say that the momentum of A before collision plus momentum of B before collision is equal to momentum of A after collision plus momentum of B after collision. So friends, basically this statement is stating that if there are two bodies A and B, then the momentum of this object before collision plus the momentum of this object before collision will be equal to the momentum of this object after collision plus momentum of this object after collision. This can be stated as total momentum before collision is equal to total momentum after collision. So guys, in the derivation of this statement, I will prove at the end that the total momentum of these two objects before collision will be equal to the total momentum of these two objects after collision. Now I will switch on to the derivation of law of conservation of momentum. Derivation part. Suppose there are two objects A and B moving with velocities UA and UB respectively in a straight line such that UA is greater than UB. Now, I will divide it into three parts. This is before collision, this is during collision, and this is after collision. In case of before collision, there are two objects A and B. Let the mass of object A is ma and the mass of object B is ma. Ma is moving with an initial velocity ua and this object is moving with an initial velocity u. From the arrows, you can easily imagine that both the objects are moving in a straight line in the same direction. Here it is mentioned that the velocity, initial velocity of object A is more than initial velocity of object B. UA is greater than, as its velocity is greater than the velocity of object B, after certain time, both the objects will collide. Now, during collision part, this is object A and this is object B. During collision of these two objects for a certain time t, both the objects will exert a certain force on each other, such that object A exerts a force FAB on object B and in return object B exerts a force FBA on object A. Now the after collision part. Now friends, if these two objects which have started with initial velocities UA and UB, definitely after collision the velocities will change. So the velocity of object A will change from initial velocity UA to final velocity V. And similarly, the velocity of object B will change from initial velocity UB to final velocity V. After this, I will signify the notations related to the mathematical part of this derivation. Notations: ma, mass of object A, and B, mass of object B. UA, initial velocity of A. UB, initial velocity of B. VA, final velocity of A. BB, final velocity of B. FAB, force exerted by A on B. FBA, force exerted by object B on object A. After signifying all the notations, I will switch on to the mathematical part of the derivation of law of conservation of momentum. So friends, condition I explained you earlier in the during collision part, where both the objects are applying a certain force on each other. That is, object A is applying a force FAB on object B, and object B in return is applying a force FBA on object A. By Newton's second law of motion, by Newton's second law of motion, force is equal to mv minus mu upon t, where m is the mass of the object, u is the initial velocity of the object, v is the final velocity of the object, and t is the time taken. Now using this formula, I will calculate the force FAB and the force FB. So force exerted by object A on B. So FAB will be equal to MB VB minus MB UB upon T. So this is equation 1. Similarly, by using this formula, I will calculate the next force, that is force exerted by object B on A. So FBA will be equal to MAVA minus MAUA upon T. So by Newton's second law and by using the formula of force, I have mentioned the formulas of both the forces FAB and FB. Now, friends, Newton's third law states that every action has equal and opposite reaction. So in this case, there are two different bodies, A and B. So let the force exerted by A on B be considered as the action force, and the force exerted by B on A be considered as the reaction force. By Newton's third law, FAB will be equal to minus of FBA, because FAB is the action force and FBA is the reaction force. So Newton's third law states that every action has equal and opposite reaction. So that's why the magnitude of both these forces will be equal, but the direction will be opposite. Now I will insert the formulas of FAB and FBA from here. After inserting it, I will get MBVB minus MBUB upon T is equal to minus MAVA minus MAUA upon T. Now cancelling T from both the sides, I will get MBVB minus MBUB is equal to, I will open this bracket, minus MAVA plus MAUA. Before proceeding further, I will rub it off. So I will write down the final statement. MBVB minus MBUB is equal to minus MAVA plus MAUA. Now friends, I will shift MAVA to this side and MBUB to this side. So it will become MAVA plus MBVB is equal to MAUA plus MBUB. Because here on the right hand side, the sign of MAVA was negative. By shifting it to left hand side, it will become positive. Similarly, the sign of MBUB on left hand side was negative. by shifting it from here to here, it will become positive. Now, by rearranging it, I can write it as MAUA plus MBUB is equal to MAVA plus MBV. Thus, this is the final formula to be derived for the law of conservation of momentum, because I have stated you earlier the two conditions before collision and after collision. Here the velocity of A was UA, the velocity of B was UB. Their masses were MA and MB respectively. Similarly here, the masses were MA and MB respectively, but the velocities changed to VA and VB. So, the momentum of object A in this case will be MAUA, and the momentum of object B in this case will be MBU. The momentum of object A in this case will be MAVA, and the momentum of object B in this case will be MBV. So the total momentum before collision will be MAUA plus MBUB, and the total momentum after collision will be MAVA plus MBVB. According to the law of conservation of momentum, the total momentum before collision is equal to the total momentum after collision. So, MAUA plus MBUB is equal to MAVA plus MBVB. Friends, as you can see that both these equations are same. So, this is the total momentum before collision and this is the total momentum after collision according to this. Thus, I have proved that the total momentum before collision is equal to the total momentum after collision. With this, friends, I have stated and derived the law of conservation of momentum in this video. I hope you have enjoyed this video of mine. See you soon with some interesting topics of maths and physics class 9th and 10th.